Welcome, everyone. My name's John Clark. I'm going to be moderating a panel discussion here that really brings or evidences that the new reality is here. In this particular case, joining me, we have Priscilla Nagashima-Boyd from Siemens Mobility. She's a data analytics leader, senior manager of data analytics with Siemens Mobility, and also Cyril Lemon, who heads up HERE's automotive product marketing organization. We're talking about a lot of sensor data from vehicles. We're talking about location data and bringing these together to solve issues of mobility through cities. So very much this new reality. First of all, you've described it, Priscilla, as establishing green waves through cities. Perhaps you could help us understand first what a green wave is, and why it's so important in this new reality.
Sure. So if you imagine you're going through traffic and you feel like it's a real lucky day, you keep going through green light after green light after green light, and you think it's just luck. Actually, it's not. It's traffic engineering. That's the idea of green wave, is when you have that continuous flow through a corridor with green lights, and that's what a green wave is about.
And I mean, I love it. I used to live here in Las Vegas. Desert Inn is a very much a green wave corridor. So I understand the benefit to me, but what's the benefit to cities in establishing these green waves?
So if you think about the corridors as where you have the biggest amount of cars, the highest volume, you really want to get those cars through the intersections as quickly as possible, so that not just as a driver you can get from A to B as quickly, as reliably as you can, but also because you're wanting to really clean up and remove the clog up or the congestion, right? So if you have these corridors flowing better, then you have traffic flowing better. So that's one of the benefits, is the congestion side. But there's also some other side effects to congestion, such as the obvious impacts to air quality. So if you are stopping at red lights, you're braking and accelerating. That's using fuel, that's consuming more of the air quality that could be improved if you were just simply going through and not braking and accelerating necessarily. So there are some other benefits to it. It's not just about getting people flowing, but obviously removing and reducing the congestion as much as possible is always going to be welcomed by the cities.
I'm sure, and you've been working with cities to actually achieve this. Tell us a little bit about some of the green wave optimization projects that you've been involved in, and how location data helps in establishing these green waves.
Sure. So we did a project in Germany last year in Aachen, where we took data from here, per vehicle data, where we could tell where the vehicles were, at what time, what location exactly, what speed they were going, what direction. So essentially, you could see the flowing for the city just purely from the per vehicle data. Now, from there, you could then establish the sort of patterns where green waves could be beneficial. So you can see where the areas of congestions are, and so on and so forth. So the project that we established was all about taking that data, creating a mechanism for analyzing and recommending solutions for those green waves, rather than having the traditional option, which would be a city commissions a traffic engineer to sit by the side of the road, and then you have like a counter. I don't know if you guys have seen that before, but you have like someone sitting outside the road with a counter, just literally seeing how many vehicles there are at certain times of day, and then they write it down, and that's how the traffic engineers are programming the green wave approach for the intersections. So the project that we did here was all about getting the per vehicle data that was already there, automating some of that, and then creating a mechanism using AI and machine learning to actually recommend where green waves could be beneficial to the cities.
Fantastic, fantastic. Cyril, welcome. Talk to us a little bit about what was that data, how was it provided, what it was supplemented with from a HERE perspective.
So we are, as Priscilla was explaining, moving into a world where there's a convergence of trends where AI, ML, and sensor explosions and connectivity everywhere are able to apply machine learning and artificial intelligence to create new solution, new location services that we were not even thinking about 5 years ago. So the way we are involved into this project was to sort of like take an assessment of existing infrastructure, which is sort of like lasting for the last 20 to 30 years, and start to think how we can provide location data to your solution, to your services, to help solve these market challenges of traffic congestion, which is kind of like 30% of the transportation industry, is 30% of global pollution. So that's a big issue. So what we are providing there in this project is mainly two types of data. One is raw car probe data, where we provide information about car data riding on the road, where we provide speed, heading, positioning, and time information. So this can be ingested into the algorithms that Siemens Lab is delivering, and so they can sort of like merge different data sources together to create that green waves. The other type of data that we are providing there is sort of like data for visualization. I think there's a component in that story also to help city to better understand, assess their situation. So what's the status quo, what's the situation right now? And then visualize this information and the benefit for the end users. So providing that location data as well serves to basically visualize and understand what's the situation and what's the benefit to move forward together in that direction.
Fantastic. Now, listen, I'm going to be opening the questions up to you in a couple of minutes. So if you've got a question, please put your hand up. Anna will come by with a microphone. But before we do, Priscilla, what have some of the major breakthroughs been? You know, you talked about, we're talking about a lot of data versus engineers sitting with a counter. That's a lot to process. That's a lot of value that can be extracted. What are some of the key breakthroughs that you've been able to achieve?
I think for us, from our experience in this field, a lot of the cities that we talk to, when they build green waves, it's either based on these very laborious studies that they do with the counters, or it's based on their gut feel. So maybe if I live in Austin, Texas, I know where traffic congestion is, I know where the busiest roads are. So as a traffic engineer, I would be, okay, I know these are the corridors where I should be establishing green waves, and that's going to be the benefit. However, what we found through our study with the data is that sometimes there are some corridors that would really make a difference, yet you don't necessarily know. It's not obvious to most traffic engineers. It's not obvious from the studies that they're doing that actually those corridors, if you deploy that green wave, so we have that lucky day every day, it will really make a difference. So I think that was probably the biggest breakthrough that we found in the whole project. But I think also the fact that we can make use of data that is already there for a new purpose, make use of data to solve a problem that would actually help people and would also help the cities with the congestion and the air quality problems. You know, it's great. It's a win-win for everybody.
Fantastic. And as I think about that, it would seem then that one of the principal benefits that taking large amounts of data from here, marrying it with the algorithms that you're defining for the machine learning, time. Mm-hmm. So talk to me about what a typical time frame would be for an engineer-based study versus getting to a similar outcome or even a better outcome using applying this data in machine learning. Yeah,
it's crazy. I mean, if you think about it, most countries out there will have a very defined public procurement process. For sure, this is the case in the US and the European countries that I've worked for. And as a result of it, they all have to go through this process of publishing a request for proposals, getting a consultant involved, getting the study done, commission the people to actually sit on the roadside, sometimes blocking lanes. You're talking months. To actually get that. And also, cities don't have endless amounts of money, so they have to be very careful with where they commission those studies to be done and when they commission it. So you're really talking months to get to a green wave that may be good or may not be good. Whereas with the data approach, you're really talking days. I mean, it's all a matter of getting the data, retrieving, doing the analysis, coming up with the recommendations, giving to the traffic engineer, going on the roadside and deploying the change to the signal plans. So it's a significant benefit to the cities. It makes it a lot easier, a lot safer. You're not having to send people out there on the roadside. And at the end of the day, it means that you can scale really quickly.
Absolutely. You know, from months to days, who doesn't want that? You know, so
There you go.
any questions in the audience? If not, I've got a couple of others here. What is really wanting to understand from, let's go, Cyril, what would your advice be for cities? You know, what is a key learning that you have? And I'll ask the same thing, Priscilla, from you. So what's a key takeaway for, you know, cities in this context?
I think it's very important to help city authorities to understand that based on the tremendous volume of data that are available in the city, we can merge them, aggregate them together to create a better ecosystem in terms of mobility. So we have a concrete example with green waves. We could basically develop many other examples to basically show the value of like ingesting data into algorithms. So my advice for city would be to sort of like tap into opening the data and give access to the data to basically sit together with commercial organizations as we are, both citizens and city authorities all together on the table and open access to the data. So they are unsiloed from that perspective. That's the first step. The second one would be to sort of like start to think about harmonizing the data ecosystem, because having access to the data is not enough. We need to provide some sort of like standardization behind the data so they are useful. And using the marketplace that we are using right now, providing location context, time information to the data can help to harmonize the data. So that would be the second one. And then it would be to explore with city authorities, like assess their current situation, prove that we can make the life of citizens in big cities better, more efficient, more comfortable, with less traffic, less pollution, and then move to the next steps to maybe simulate or implement that solution at a global scaling.
Fantastic, thank you. Priscilla?
I think that was perfect. I think that's exactly it. I think if I just had to give one piece of advice to any city out there when it comes to the results of this project is you can do so much more with things that already exist, that in front of you, you have partners in industry that are wanting to work with you. Engage, you know. I think we have been very fortunate that we had cities that worked close with us, and we tried things, and sometimes it worked, sometimes it didn't, true. But the benefit at the end of the day, if it does work, is immense. It means that you don't have to go out, you don't have to procure new equipment. It means that you can make use of things that are already there, and it gives you a very clear benefit. If you're going from months to days, I mean, the business case is very obvious. So if I could give one piece of advice, it would be, you know, just look for partners and engage very early, because the benefits are there.
Yeah, very, very, very important point. You know, no one organization can solve everything on their own. That very often, you know, what we see is emerging business models where it's more of an ecosystem approach. One final question then. What makes here such a good ecosystem partner or contributor to Siemens' efforts?
Well, we've worked with here as a supplier for a number of years, and for us, we always saw the company as a market leader in the space, and we had this thought that maybe if we could have access to more granular per-vehicle data, we might be able to find a use case and a benefit to a customer that we can quite easily develop and quite easily test. And I think for us, it was all a matter of understanding the kind of strengths that we as a company can bring to the table for those cities, but also we already knew you guys, and we already knew that you had the data that we needed, and working together really allowed us to come up with this, and I think it's really cool. We work with other partners out there, academia and so on. We know that it's not possible to build everything ourselves. That's very key. And I think he has been very collaborative with us and very supportive, and I think we saw the benefits at the end. It's been great.
Fantastic. Well, listen, let's hope that many more cities create these green waves so that we can all benefit. To the audience, for anyone that is interested in more topics around urban mobility, we do have on Thursday at 2 o'clock here with the City Tech Collaborative, Rethinking the Curb. And also, in terms of these various different experiences here, two of them that come to my mind. One behind us is the reducing traffic, where I think we're very much talking about the same kind of approach, and then also the seamless mobility. So a couple of different topics if you want to explore further. With that, thank you both.
Thank you
Really
very much.
appreciate it.
Thank you. Thank you for
you.
having me. Thanks. Thank you.